Hello everyone, welcome to our channel. Today in this lecture we are solving numerical related to irrigation engineering, where we'll design a canal. The head regulator of a canal has a 3 opening, each 3 meter wide. The water is flowing between the upper and lower gates. The vertical opening of the gate is 1 meter. The head on the regulator is 0.45 meter. If the upstream water level is raised by 0.2 meter, find how much the upper gate must be lowered to maintain the canal discharge unaltered. So let's start solving this. In first case, when the gate opening is 1 meter, discharge can be calculated by Sommer's orifice formula. That is Q equals CD dot A equals root over 2GH. Times of 2GH equals 0.62 times of 1 times of 9 root over 2 9.81 and 0.45. In second case, when upstream water level raised by 0.2 meter, upstream water level (0.2 meter), let the gate opening be X meter to keep the discharge unaltered. Q equals 0.62 times of X times of 9 root over 2 times of 9.81 into 0.65. On equating equation 1 and 2, that is 0.62 times of 1 times of 9 root over 2 into 9.81 times of 0.45 equals 0.62 times of X times of 9 root over 2 into 9.81 0.65, or 1 root over 0.45 equals X root over 0.65, or X equals 0.45 is divided root over 0.65. So on solving this, the value of X will be 0.83 meter. So the gate must be lowered by n 1 minus 0.83 equals 0.17 meter, which is the final answer. So for this time we end up the video. After this much, we will come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.